So object-oriented programming. So object-oriented programming software designed to make it easier to understand, maintain, and reuse. So if you see the function module program that we have done, the concept was, the program was very simple. The program was simple. It was very easy to understand. Program was very, very simple. But even then we have the output loop was very better. So you were wondering, where is the loop statement? Even though we didn't have the loop statement, the function model took care of the entire output. So similarly here also we have the object-oriented programming. So object-oriented programming represents a different way of thinking and writing the software. The beauty of oops lies in the simplicity. So in the front end, it is very simple. In the back end, we might have a lot of complex codes written in the classes. Okay, so we have used function modules, right? So function modules is a modularization technique wherein you have written the function module is already been written somewhere and it is maintained. We just make use of that. Similarly, here we'll have classes. In object-oriented programming, we have classes. So object orientation simplifies software design, and the main feature of object-oriented programming is representing real objects in the form of class objects. So real objects in the form of class objects, in the sense, basically let's say, what is real-time scenario, what is object-oriented scenario, and what is structured scenario. I'll just give you an example. Let's say you have to travel from one place to another place in a bus. So what you do, you have to walk to the you have to walk towards the the bus, wait in the bus stand, and then from the bus stand you have to uh, take the bus and then get down in another bus stand, and then uh, walk from there into near to the place that you have to reach. So what you're doing is, in structured programming you have to adjust according to the structure, according to the programming standards. But whereas object-oriented programming is like customized, like you can use whatever you want according to your business requirements. For example, like a cab. In cab, how the cab is not something which cab is not something which you have to wait for it. You will be uh, you will be you will be booking a cab and it will come near to you, and then it will also drop you at one particular place exactly in front of the shop that you have to travel. So it's like, business object programming always works on the business requirements. Based on the business requirement, it will works. This is what we have. So now we will be, see, first and foremost, the simple thing that you need to understand right now is that we will have a class and we'll make use of that class. We'll write some code in the class that we have to use it in our program. That's the main concept here. Okay, just like we had function module, we have written some logic in the function module and then we made use of that in our program, right? So same thing here. So you make use of you make use of that class in our program. So the class might be a global class or a local class. So the class might be a global class or a local class. Now, first we'll create a simple program in which we are going to make use of a local class, and then we'll go for the global class later. So the advantages of object-oriented programming are better programming structure, a real-world entity can be modeled very well, stress on data security and access, reduction in code redundancy, data encapsulation and abstraction. So there are four properties which needs to be satisfied by a programming concept to to name it as object-oriented programming. Okay, so what are these four concepts? Is the four major concepts that you have to that a programming should satisfy. It's first one is abstraction. Then we have encapsulation, polymorphism, inheritance. Inheritance. So these are the four major concepts which an object-oriented programming have to satisfy. Only then it can be called as a object-oriented program. So in this, like abstraction means declaring something and using it in a program. Declaration and usage. Encapsulation, we have a code. Like for example, your phone is encapsulated, your mobile laptop is encapsulated. So your car is encapsulated. So what exactly do we mean by encapsulation is everything is covered and we just have to make use of it through some input and output. So you are not worried about what is there inside the mobile phone, what concept is there. You just have to worry about how to switch it on and how to make use of that. So we are only making use of the products instead of understanding what exactly is inside it. uh, we always learn how to drive a car, but we never learn how what exactly is the car made up of, how it was made up of. All these are not required actually. So encapsulation is say kind of covering up, but that does not mean that you are hiding something. So it's like hiding only, but you're it's not that you cannot see it. If you have the access, you can also go and see the program, but we are not worried about that. So if you have used the function model reuse underscore lv underscore print underscore display, what exactly did you learn? You learned how to use it, that to a few options which are required for the project. But we are least bothered about what is the code written inside and what is how the logic works and all these things. We didn't work upon those things, right? So that is about encapsulation. Encapsulation is like covering up and then we are making use of that. So a programming concept has to satisfy encapsulation, only then it can be called as a object-oriented program. Polymorphism means same code, same logic that we have written acts differently in different classes. Same logic acts differently in different classes. Different classes, different logic. That's polymorphism. So, for example, you have switched on the second switch in a particular classroom. Classroom number one, you have switched on the second switch. Then light might be on. I mean, like the tube might be on. And the same second switch, if you switch on in the class two, then maybe the fan might be on. So here, the concept that you are doing, the logic that you are writing is same in both the classes, but it acts differently in different classes. That's about polymorphism. Inheritance is the ability to adapt the properties of another class. So inheritance means from grandfather to father to son. So it's like that. So there's a grandfather. From grandfather, father inherits something, and from father, son inherits certain features, right? Similarly, inheritance means from superclass to subclass, we copy certain properties. But that does not mean that once you have copied, it will be permanent. You can override them with new properties as well. For example, you have defined A as a character in the superclass, and you copy the properties of a superclass. Then you have to you can also update from numeric to character also. You can update that from numeric to character. We can update that in the subclass. So here we were understanding about the concept of object programming, and in this, as I was telling you, that every object programming will make use of classes, and these classes can either be used, either be declared in the global, or it could have been also used in as a local class. So we have objects. So an object is a section of source code that contains data and provides services. The data forms the attributes of the subject object. The services is known as method. So as of now, you can just understand that method is something where we have to write the logic. We will be writing the logic in the method, and classes describes the object. So now, what is an object? Object is an encapsulation of a class. Object is an encapsulation of a class. So we'll be creating global classes and local classes. Local classes will be doing it in SC38 transaction in the program itself, which we'll be doing it now. And SC24 will be creating the global classes. So we have this definition. This is a definition, and this is the implementation. Structures of classes, components of class. We have, so what will be there in the classes? We'll have attributes, and methods and events, and interfaces also will be there. So what we'll do is we'll just do a simple program, understand, and then come back to this. So let's use a simple class now. Let's start with a simple class. So I'll go for class C1 definition. class C1 definition end class, and the name of the class is C1 now, and we need to have a definition, and in the definition we are writing some methods M1, and then we have class C1, same C1 we should have implementation and end class. So we should be having class definition, class implementation, and whatever methods that we declare in that definition should have the implementation here. Method M1 and method. So let's say write, this is a simple write statement. I am method M1 from C1. This is what we're writing. And then we'll be going ahead with the program. So this is what we need to understand. So what I was trying to tell you theoretically is, for every class there should be a definition and there should be an implementation. In the definition part we do some declarations, and in the implementation part we do some implementation part, wherein like we are writing this whatever methods that we have here, for which we need to write the logic in the implementation, and we are writing the logic is the write statement is what we're writing. Go ahead with the data obj type ref to C1, obj type ref to C1, obj type ref to C1. Now what is obj is object. See, we cannot use the C1 directly. Remember in the previous programs, just if you remember the structures, in the structures we were not using structure directly in the program. What we are doing, we were declaring something in the structure, and then we are copying the properties of the structure into internal table and work area, and then we are using the work area in our program. So that's how it is. Like we are not using the class directly in the program, we are using the object. So then we have startup selection. Create object, create object, obj, create object obj. So what are we doing here is, we have two steps to create an object. One is we have to write obj, we are at write that object type ref to C1, whatever class name is there. We have to write this type ref to. Type ref to is the syntax. Then we have to go for startup section. In the startup section we have create object obj. Then what we are doing is we'll be going ahead with the we'll be creating create object obj, and then we'll call this call method obj m1, obj m1. So we need to tell to the system if it is public section or private section. So we have public section. So we'll have three sections. One is public section, private section, and protected section. So we need to give it in the public section, and then we have this class C1 implementation. Now let us understand this program. Let us understand this program. So we have class C1 definition, class C1 definition, and class C1 implementation. So class C1 definition, we are declaring one method which is under the public section. So we can have public section, private section, and protected section. I'll come to that slowly, one after the other. As of now, we are declaring it in the public section. So now we are writing the methods M1, and the class C1 implementation method M1 Right? Am method M1 from C1. Then what we'll be doing is, like here we have this end method. So we are writing this logic, whatever logic which we have written here will be displayed when we are calling it from the program. The actual program starts from the line number 19. The actual program starts from the line number 19, in which what we are doing, obj typed up to C1. The C1, we are copying the properties of C1 into obj. Now everything that we declare in the obj will be there in the everything we declare in the class will be there in the obj. And we have this startup selection, create section, create object obj, then call method obj m1. This is what we are doing. So there will be three sections in the class. One is public section, credited section, and private section. Public section, whatever you declare here can be accessed by outside the program, by any other class and in the program also. Protected section can be accessed only by the class and its subclasses. Private section, you can't even access it from the subclasses also. You can access it only from within the class. This is what we have. So class, and that's how we have done that, and we have assigned the values here. But if we are calling it from the program, it's coming only the first one is coming because it's declared in the public section. So what we just did is we just we went call method, and we are calling the second method. So each individual method have to be called separately, individually. So first we are calling the method M1, then we are calling the method M2. So the visibility section of a class will be there in the definition part of a class. In the definition part of a class, we can declare everything that we want to declare under public section, protected section, and private section. These are the three sections in which you can declare anything in the definition of a class. If you declare anything in the public section, it can be accessed by the class, its subclasses, and outside the class also. Protected section can be used by the class and the subclasses and its subclasses, class and its subclasses. Private section, the same class can use it, and only the class can use it. Not even the subclasses can make use of whatever we have declared in the private section. So this is the flow. This is the order. This is the this is the order in which you have to declare everything in the program. So public section, protected section, and private section. So this is what we'll declare now. Class definition. Here we'll get the class name, and we'll have the public section, protected section, and private section. Three sections will be there in the class. So in the public section, we'll declare whatever we can declare. We can declare three things in each section. Like one is the attributes, that's a declaration part. methods, and events. The three things that we can declare within all these things. And every method that we declare in the definition part, we should have a implementation in the implementation of the class.